Welcome. So, we are trying to work with Octave. I showed you how to use Octave like a calculator. Now, we are going to go one step further and we are going to see how to use Octave both as a calculator and as a plotter. Okay. This is a program which can also plot and show. To do that, of course, we have to go and invoke Octave. So, this time I am going to do it from the icon. So, you go find out the Octave icon, double click it, you got Octave. I wanted to calculate the vacancy concentration in aluminum for temperature range 300 to 600 and I wanted to calculate it for every 10 degrees. So, first I am going to define a variable called temperature T and I am going to define it to be a vector. It will go from 300 to 600, it will go 300, 320, 20, 330, 340, 350 etc. up to 600. Well, how do I do that? Here is how you do that. So, you first say T, that is my variable name, is equal to 300, then colon, I say increase in steps of 10 till what point? Till it reaches 600. So, I am going to enter. So, you can see it has columns and the columns are what? 300, 310, 320, 330, 340 etc. And okay, let us go forward. So, it goes up to 600, right. So, if I say Q, now it will come out. So, I have temperature now stored from 300 to 600 in steps of 10. Now, I want to calculate the vacancy concentration. Let me call the vacancy concentration as X. X is equal to what? Exponential. This is where I said, when we looked up the exponential, it said that it will calculate it for a matrix or vector. This is what it means. I have temperature stored as a vector and when I say exponential of that quantity, then it is going to do for every component of that vector. Okay, so that is what we are going to do. How do I calculate exponential, right? Of course, minus 68,000 divided by RT or is 8.314. It is always a good idea to put this parenthesis first and write the remaining command, so that you will never get syntax errors, that you open a parenthesis and you have not closed it. So, you will not get it. And then I am going to multiply, star is for multiplication. If you say dot star, then that means multiply for each of the components of the given vector and that is T for us, right. So, let us see what happens if I enter. Okay, so some non-conformant argument. Okay, I do not understand what it is. Let me see, maybe I have made a mistake here. No, I can't do this. Okay, so I am going to do this. So, let me make a temporary variable. Let us see if this works. This is minus 68,000 divided by 8.314 dot star T. Let us see if this works. Okay, this works, very good. So, we now have a vector y which basically calculated minus delta h by RT, very good. So, now I say that some quantity z is nothing but exponential of y. Okay, let us see if this works. Well, this works, very good. Okay, now what do? I need to plot which is the x axis, that is temperature, which is the y axis, that is z. So, let me enter. I have the vacancy concentration. You can see that vacancy concentration is very low. Of course, it increases exponentially because that is what the functional dependence we saw, right. So, I hope you are able to see the numbers. I do not know if they are clearly visible. So, it starts from somewhere 0, 300 is very small, it is not quite 0, you saw that it is 10 power minus 12 or something, but this is 5 orders of magnitude high. So, by the time you reach something like 25 or something, you are in 10 power minus 7, and by the time you reach something like 600, you are in 10 power minus 6. So, from minus 12 to minus 6, so 6 orders of magnitude your vacancy concentration has increased. Of course, this is exponential dependence because that is what the dependence that we are trying to plot. Okay. So, you can use Octave, you can do calculations, calculations which you would have thought, or if you had programmed in a programming language like C for example, first you have to generate a loop, and the loop has to go in steps of 10, and then you have to calculate that value for everything, then you have to store them, and then that has to be written to a file in a format which some plotting program can read and then plot. Okay, so that is how you would have done it if you did not have access to a simplified program like Octave. So it is very high level, as you can see. It is also interactive. What it means is that if I type something, it immediately tells me what the answer is, right. I say from 300 to 600 you go in steps of 10, then it immediately shows me what all these steps it is going to take. But there is a way to avoid that. Sometimes I do not want things onto the screen, so I will show you a small trick which helps avoid printing to the screen, and that is something like this. Okay. So if I say 300 to 600 go in steps of 10, but do not show me the output on the screen. So you just have to put a semicolon at the end. If you say semicolon and then enter, then it will not show anything on the screen, but it has produced this T. Okay. So if you just say T and then enter, it will show you that this is what it has stored. Okay. So the semicolon basically suppresses output to the screen. Sometimes we do not want to see all these big things on the screen, so you can put a semicolon and forget about it. So it will not show you on the screen. Okay. Now very good. So we can do a small exercise. You remember the Stirling approximation that we were looking at earlier. The Stirling approximation said that logarithm of n factorial, right, what did it say, logarithm of n factorial is equal to n log n minus n, right. We said that this approximation is good for very large numbers and things like that. So let me find out how good this approximation is. Okay. So we are going to take some numbers from 2 to 20 and see how the approximation is performed. For doing that, you need to know what the factorial is, right. You need to calculate for 2 factorial, 3 factorial, 4 factorial, etc. up to 20 factorial. You have to take logarithm on that, and you have to compare that with this number. So the way I am going to compare is that I am going to define a quantity called error. The error is something like this. It is a relative error. So I am going to take log n factorial minus n log n minus of minus n, so it becomes plus n, divided by logarithm of n factorial, because logarithm of n factorial is the actual value. Okay, this is the approximation. So when I make this approximation, relatively how much error am I making is what my error is going to be. Okay, so this is the quantity I want to do, and I want to plot this error as a function of n. Okay, so I want to have a plot of E versus n. This is what I want to do. Well, we know how to do that, provided we know how to do the factorial calculation on Octave. Okay, so my first step would be to ask for help from Octave, and I am going to ask help factorial. I hope help factorial will give me help on factorial. Okay. So how do I do that? Help space, let us ask for help on factorial, right. Very good. So there is a function called factorial, and it do factorial. So it says return the factorial of n, where n is a positive integer. Okay. So if n is a scalar, then this is equivalent to product of 1 to n. So of course you know that that is what factorial is. 3 factorial is 3 into 2 into 1, right. So for vector arguments also it works. So now you know what vector argument is, and for non-integers, see the generalized factorial function gamma. See, this is one of the reasons why I like Octave, and I strongly recommend that you actually go through the manual and all the available information. So you can actually learn Octave. As you are learning, if you are paying attention to the manual and document and other information, you will also learn lots of mathematics. And on top of it, because this is an open source software, you will even be able to see the code that generates these results. So you will be able to learn a lot about algorithms and coding and everything. Okay, so this is one package, and this is the great thing about free open source software, that they are great pedagogical implements. So they are very great from the point of view of learning. Okay, instead of somebody teaching you all the stuff, they are available, and the worst that you can do by experimenting with them is that maybe you will make your computer hang, right? Nothing worse is going to happen. So you can learn lots of information and lots of concepts and lots of material on your own, just by putting one of these programs on your computer and playing with them and trying to read about them and trying to learn about them. Okay, so very good. So we are going to do this factorial thing. So factorial n exists. So what am I going to do? I am going to first calculate. First I am going to define a variable. Let me call that variable as a. What is a? A goes from 2 to 20. Okay, so as you can see, previously I said 300 colon 10 colon 600. So then it went from 300 to 600 in steps of 10. If I skip the middle colon, if I say 2 and 20, the initial and final alone I give, then it increments by 1 by unity. So it goes 2, 3, 4, etc. Okay. So if you are incrementing things by 1, which is the most default way of increasing numbers, then you do not have to give the increment value in between. In other words, 2 is to 20 is equivalent to giving it as 2 is to 1 is to 20. Okay. So they are the same. Alright, so I have this variable, I called it as a, and a is from 2 to 20. I can calculate the error. Let me define E is equal to, I am going to do this divided by that. I always put the parenthesis first so that I do not miss them, logarithm of factorial of a, right, minus a into logarithm of a minus a. No, that is plus a, right. N log n minus n is the approximation. So minus, if I do, then first one becomes minus, the second one becomes plus, divided by, of course, logarithm of factorial of a. It is quite complicated. Let us see how it works. Did I forget some parenthesis? I do not think so. Let us see. I did forget some parenthesis. Okay. So if you get to this, then the way to come out of this is to put control C. Okay. So I did forget some parenthesis, I think here. Okay. So let us see if it works now. No, there is an extra parenthesis. So it says that there is some syntax error. I am not able to figure out. So let me rewrite it again. E is equal to divided by this, and this part is logarithm of factorial of a. Okay, one parenthesis I missed. Okay, so logarithm of factorial of a, okay, minus a. If you pay attention, it actually shows me where the parentheses are. I mean, it does keep track of it for me and tell me. Okay, so let us see if it works. Okay, so this is telling me the non-conformant argument means that you are dealing with a vector and you want to do this for every element of the vector, in which case you can't use star, you have to use dot star. Okay. So I am showing you these error messages because most of the times when you do calculations, sometimes you will get this kind of error messages, then you should be able to guess what the error could be and then correct it, right. So for example, here it showed that this is where I made a mistake, because I thought that I missed a parenthesis, I put it here and it is telling there is an error here. It says syntax error, parse error, which means this parenthesis is extra. Similarly, here it is telling operator star non-conformant argument, operation 1 is 1 into 19, operation 2 is 1 into 19, which means, okay, so it is talking about some vector operators here, and the dot is missing. So, that is what I understand. Okay. Okay. So, we have error, but this is not the form in which I want. Let me see what has happened. No, this is not the form in which I want. I want the error for each of the A's. Okay. So, I am going to go back and redo this calculation. The way I am going to do is like I did in the case of plotting the vacancy concentration. So, I am going to introduce two vectors and I am going to deal with vectors. So, let me first create the logarithm of n factorial. Okay. So, how do I do that? Let me call this y is equal to factorial of a. Well, now y is a vector. Okay. So, now I can say okay, logarithm of y minus a dot start logarithm of a, okay, minus okay. So, so what did I plot? So, logarithm of factorial n factorial minus a log a minus a, right. This is the approximation. So, now let me take this quantity and divide by logarithm of factorial of a, right. That is the log of y, and that quantity I want to call as error E. Okay. No, I have made a mistake again. So, where did I make the mistake? So, let me call this as error. No. I don't know. Probably I missed okay, very good. Okay. I get some number again. This is not what I want. Okay. So, let me do it. I have a, okay. If I say clear, all things go away. So, a is gone. So, let me redo it. A is 2 to 20. Okay. Y is factorial of a. Okay. Now, log of y is log of factorial of y. Okay. Now, a, so let me call this as z. This is the approximation log of a minus a. Okay. So, now I have y minus z, okay, and divide by y. So, each component of y I have to take, I have to subtract the z component from there and divide by the corresponding y component, and that is what I called it as error. So, I have the error. So, I can now plot a times error, right. A is nothing but the n 2, 3, 4 etcetera up to 20, and E is nothing but the error that you calculate for those quantities. So, if I plot, you can see that initially the error is high and then it is coming down, but why does it come down to 1? You should not be getting 1. Okay? There is something still wrong. Okay. So, let me calculate again. A is 2 to 20 and factorial of A is let me call as y is equal to factorial of A. Okay, this is correct. Now, logarithm of y let me call that as Z is equal to this quantity. Let me call a quantity called B, that is nothing but A times logarithm of A minus A. Okay. Now, I had the quantity called Z, which was logarithm of Y, and I now have this quantity. Okay. So, and this quantity is called B, right. Z is basically logarithm of factorial of n. So, Z minus B, okay, is this quantity, and Z minus B divided by okay. So, E is equal to Z minus B divided by the Z value. Okay, now I am getting it right. So, let us plot this quantity, plot A comma E, right. Now, I have got it correct. Okay. What happens as the n value is increasing 2, 3, 4, 5 etc., you can see that the relative error is coming down and it is going towards 0. So, it is a good exercise for you now to go back and do it for n values ranging from 2 to 100. You can try for 2 to 150, okay, you will get similar results. But then if you try to calculate for 2 to 200 for example, your computer is going to give up. Okay. So, you can try this exercise, go to Octave, try to define A to be from 2 to 200 and try to do the same kind of error calculation and see what happens, and it gives up, and if you know programming you know why it gives up. If not, it is a good idea to look into why it gives up. We will come back to this problem sometime later. So, to summarize, you can use Octave as a calculator and you can also use it to plot functions, and so it is very handy. Even if you do not use it for phase field modeling, you can work with Octave as an advanced scientific calculator and plotter. Okay. So, in the next one, of course, I am going to show you one more way of interacting with Octave, and that is known as the script mode of working with Octave. So, that is what I will show you next. Thank you.